Hey everyone, Mr. Fritz here. Let's talk about series. Series are a lot like sequences, but with one important difference. Let's define what a series is. A series is the sum of the terms in a sequence. So it's like a sequence. We've got a sequence of terms, but now we're just going to add them all together. For the finite sequence, u sub n with n terms, the corresponding sequence is the first term plus the second term plus the third term plus all the terms all the way up to u sub n, that last term in the sequence. And there are other types of sequences, infinite sequences, and or rather, the infinite series is what's given by an infinite sequence when we add up all the terms forever. So this is something that usually we say it's called diverging, because if you're going to continue to add up numbers over and over and over again, that number is actually going to increasingly go forever in one direction. So just think about if you were to add up all of the even numbers, 2 plus 4 plus 6 plus 8 plus 10, that's going to keep going forever since your series or your sequence goes forever. So that's what a series is. Let's talk about just calculating the series. For this first example, we want to take the sequence 1, 4, 9, 16, 25. We want to write down an expression for s sub n, and then we want to find the sum s sub n for n equals 1, n equals 2, n equals 3, n equals 4, and n equals 5. So let's first start off by coming up with an expression for s sub n. And if this is the first term, this is the second term, this is the third term, this is the fourth term, fifth term, this looks like this is neither arithmetic nor is it geometric, since I don't have a common difference or a common ratio. But the clever among us might have recognized that all of these numbers are, all these terms are the square of n. So we could say that since all of these are perfect squares, we could say that the sum of n terms is going to equal 1 squared plus 2 squared plus 3 squared, all the way up to whatever the nth term is squared. So we can use this formula. This is like a general formula. And now obviously if we were looking for n sub 1, we would stop at 1 squared. If we were stopping at s sub 6, we would take this all the way out to 6 squared. So this is just some more way to kind of package together how we are summing this sequence for any number n terms. So let's now take the second part and let's find s sub n for all these n values. So s sub 1 is going to be given by just 1 squared, so it's one term long, and it takes the first term and we square it, so this is going to equal 1. S sub 2 is going to equal 1 squared plus 2 squared, which is going to equal 1 plus 4, which is going to equal 5. So here is the sum of all of these series for these different number n terms. While you try this problem here, this is the sequence 2, 4, 6, 8, 10, goes on forever. I want you to A, write down an expression for s sub n, and then B, write down what the sum is for these different n values. So find me the sum of one term series, a two-term series, a three-term series, a four-term series, and a five-term series. So pause the video, give this one a shot, and we'll see how it goes. All right, and here is the solution. I think the only thing worth talking about here is this part A, writing down the expression. And this is going to be kind of difficult to wrap your mind around, but as long as you see that, if you're following the pattern here, as long as you can see that the first, when n is 1, n is 2, n is 3, n is 4, n is 5, if you can see that all of these terms are double the value of n, that's where this 2n is coming from. This is kind of like the general expression for your sequence. And really we just kind of put in this 2 and 4 and 6 and 8 and 10 just to show that these are the first few terms of the sum or the series. You could have also just said that s sub n is equal to 2 plus 4 plus dot 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 plus 2n. It doesn't really matter how many of these you're using. This kind of shows us where the pattern is beginning. All right, in the next video we'll kind of take this a little bit further. We'll do some more examples, and I'll see you in the next one.